Hello guys, welcome to my YouTube channel, and in this video we are going to solve one classification problem of machine learning. So in this classification problem is about breast cancer, and we have to diagnose whether the breast cancer is of type malignant or benign. Malignant grows faster than benign. So there, let's just import our libraries and look at data. Import numpy as np, import pandas as pd, import seaborn as sns, import matplotlib dot pyplot as plt, and we will use a style type plt dot style dot use ggplot. Now we have imported our libraries. Now it's turn that we should import our data set also. pd dot read csv, and I will import our data file here and have a look at it. So we will enter df dot head. So we have imported our data, and as we can see there is a diagnose column which is our target column, which says whether the values are malignant or benign. There is radius mean, texture mean, perimeter mean, and area mean, and smoothness mean. So these are all values related to the breast cancer type. So radius, mean distance from the center to points on the perimeter. Texture, standard deviation of grayscale center. There is perimeter and area and other smoothness and compactness features in it. So as we can see there are total 33 columns in it, and now we will start data processing. Data processing. So we will start data processing. As we can see there is one column unnamed 32 which has nan values in it, and if we look at df.info, so it has got 569 rows or entries, and the last unnamed column has no values in it. So we will try to remove the column non-null and id column which is of no use over here. So for that we will write a code df.drop id we will remove the spaces and unnamed 32. Unnamed 32 with axis equal to 1, as we want to remove both the columns, and in place equal to true. That means we have to permanently remove this out. Now we have removed it, we will check it with df.head. So these two columns have been removed. Now our data has 31 columns. So first of all, we'll check the unique values in diagnosis. df diagnosis dot unique values, how many unique values are there, which is also our target column. So it has two values. M denotes for malignant and B denotes for benign. Now we will try to look at the numerical values, mean, standard deviation, quantiles, with the help of df describe function. So count means total 569 values in there. It is also showing the mean of every values and standard deviation of it. So first of all, we will try to see in the our data exploratory data analysis through exploratory data analysis. We'll perform exploratory data analysis. First of all, we will check the distribution here. So for that, I will mention plt dot figure fig size equal to a tuple value is provided here 2015. So I will mention plot number 1 variable equal to 1 for column in df if plot number is less than 30, as there are 30 columns in it. If plot number is less than equal to 30, we'll pass ax equal to plt dot subplot 5,6 comma plot number, and sns dot we will see the distribution with the help of dist plot df column plt dot x label we will provide column name colmn column name, and we will increment our plot number is equal to plus equal to 1 and plt dot tight layout and plt dot show. So as soon as I run this code, oh, there is a mistake over here, string to float mn. So first we will have to convert our diagnosis variable, then we can apply this because it is showing categorical value. For that we will use df diagnosis is equal to df diagnosis dot apply in bracket. We will provide lambda function to convert the values lambda val if val is equal to m, return 1 if val is equal to m, else 0. So this will also convert our variable. Now it is a numerical. Now we can see the distribution plot of it. Now we can see the distribution plot, which almost shows normal distribution of the variables. So after this we will move further and derive the correlation among the variables plt dot figure fig size
अंकित के पहले हम
so plt dot fig size my battery is running low. So plt dot fig size, I will pass a tuple and try to draw a heat map of this correlation. 2012. So core is equal to df dot core and mask is equal to np dot true. This function will represent half of the triangle of df because both the sides are having same values. So we will print half of the heat map. So df np dot trio np dot once like will pass core value core dot d type core comma d type is equal to bool and we will draw heat map sns dot heat map will pass core in it as a values and mass equal to mass. I will provide one line width equal to 1 line width equal to 1 and annote equal to true. FM t equal to 0.2 f, and we will print plt dot show. So it will show our heat map. So as we can see in this heat map, there are many values which are correlated and highly correlated. This can create a multicollinearity issue. In this heat map, we can clearly see highly correlated columns that can bring multicollinearity issue. For this, we will remove those columns. So now for that I will write one core matrix, core underscore matrix, and I will take df.core dot abs, absolute value of it. Now I will write mask, same mask which we have used here, mask equal to np.trio np.once like, and we will pass core matrix over here, and try df equal to, we'll write return x for x in okay, first we have to define this try df. So for that I will write core matrix dot mask, and we will pass the mask value. At this mask function does whatever condition is present, it applies over the entire data frame which we have created and try to sort out the values. Now I will write to drop is equal to, for x in try df dot columns if any try df x is greater than 0.92. So for in true drop we are trying to extract those values of our our data frame that have greater values than 0.92. So all the values greater than 0.92 will be extracted, and those columns we want to delete. So I will write df equal to df dot drop to drop comma x is equal to 1. So now I will try to print those values f the reduced data frame has df dot shape 1 columns. Now as soon as I run this, it has reduced all the columns to 23. Now we have left with 23 columns, and the columns which can create multicollinearity has been removed from our data set. So now we will separate our values in x and y. For x, I will write df dot drop so I want to remove diagnosis column as a y column, so I will write df dot drop diagnosis, and x is equal to 1. While y is our target column, it will hold target column, so we will write df diagnosis. So this will separate our values. So all dependent variables are our x, and independent variable so dependent variable diagnosis is our y, which is a target column, and other columns are x variables. So now I will try to divide this data into train and test. sklearn dot model selection import train test split. xtrain xtest ytrain ytest train test split, and either I will pass x comma y comma test size 0.2 and random state equal to 0. And I have divided my data. Now we will check the shape of xtrain dot shape 455 and 22 columns. So we have properly segmented our data using train test split. Now first of all, we will try to scale our data using standard scaler and bring it to the normal values from sklearn dot preprocessing import standard scaler equal to standard scaler. We will form one object of standard scaler, and for xtrain we will scaler dot fit xtrain and x test is equal to scalar dot, so fit, we can transform also, so I will write fit transform, and here transform x test. So it will bring to a standard scale our data. So as soon as I run this, so it have brought our data to standard scalar form. Now we will try to build our models. Model building. Model building. So first we will build is logistic regression. Logistic regression from sklearn dot linear model import logistic regression log underscore reg is equal to, we will call its object logistic regression, and I will try to pass log reg dot fit xtrain comma ytrain and ypred is equal to log reg dot predict function predict x test. Now I will fit the model using logistic regression. Now I will check the metrics, how our model is performing with logistic regression. sklearn dot metrics import accuracy score confusion matrix and classification report. These three metrics I will take out and check our accuracy in logistic regression. Print accuracy score y test ypred print confusion matrix y test comma ypred, and lastly we will print classification report using y test and ypred. Y test comma ypred. So it is showing our accuracy as 96%, which is far good, and this is the confusion matrix 61 and 344. So it is accurately doing things and showing us the result 66 and 44 accurately. Only 3 and 1 of this matrix shows that the points are wrongly classified. Similar with the classification result report also, we can see that it is showing the accuracy of 96%. Now we will try to run another that is k near neighbors, knn, k neighbors classifier, k neighbors classifier, and build another model for it and check what is the accuracy score for from sklearn dot neighbors import k neighbor classifier, and we will check knn is equal to k neighbor classifier, and default value is 5 for this, so we will let the default value be, and knn dot fit xtrain comma ytrain, and we will apply ypred is equal to knn dot predict x test and we will train our model and predict the on x test values. Now we will again bring the classification reports accuracy score and confusion matrix, how our this model is performing, which is k nearest neighbor classifier. So as we can see, it is performing little less than our logistic regression because accuracy score is 95 and it is making more errors. Last time it was making 4 errors only in the given x test data, while here it is making 5 errors. Now we will try to build another model to check whether it is performing well or not, that is support vector machine SVM, or we also can as support vector machine or support vector classifier from sklearn dot svm sklearn dot svm will import svc, and first we will create svc is equal to support vector classifier object, and then we will try to fit the values over here. For that we will describe few parameters is equal to first parameter will be gamma which will have value 0.001 0.01 and 0.1, three values for gamma. We'll also define C over here. For C, we will define values 0.01. It's a numerical value, so it will not come in braces. 0.005, 0.1, comma 1, comma 10, comma 15. And now, once the parameters are declared, we'll apply grid search CV so that it will go grid search is equal to for that we have to first import the library also from sklearn dot model selection import grid search CV. Grid search CV SVC is our object of SVC classifier, and we'll pass the parameters now grid search CV dot fit will pass xtrain and xtest. Xtrain and ytrain over here, and we will try to get best values. So C is small, I have written here. As soon as I run this, so for this I have to check value of C For now we will remove the value of C first and try to run this. So grid search CV has been applied, and we will check the best parameters. Grid search CV dot best params, that is gamma is equal to 0.1. So we will apply SVC is equal to SVC and we will pass so value of C is also there, we have to check first that. value of C. So we will check with C value also, that is 0.01, 0.05, 0.1, 1, 10, 15. Now we will rerun this. So now we will notice our best parameters value, that is C is 15. C is 15 and value of gamma is equal to 0.01, and we will try to fit this svc.fit svc.fit xtrain comma ytrain and y spread is equal to svc dot predict x test. Now our model is ready for with a support vector classifier, and we will again check the accuracy score, confusion matrix and classification reports. So this classifier has much more accuracy and values, that is 98% accuracy, and it is correctly classifying all the points. Only two values are showing error in it, so it is better than logistic and k nearest neighbor. Now we will try to build model using another classifier, that is decision trees. So for decision tree I will write decision tree classifier from sklearn dot tree import decision tree classifier. So DTC is equal to decision tree classifier object. Now we'll check the parameters first of all, which are suitable for this. That is, first one is criterion. And we will pass two values. One is Gini, whether Gini is suitable for it, or entropy. Now next is max depth. So that will also we will import max depth. Max depth will provide a range 2, 32 and with a step value of 1. Check. Now we'll check minimum samples. Min samples leaf. Min sample leaves is equal to, will provide a range 2 to 10 with a step of 1. And min sample splits also we will check for this. For this we'll provide a range 2, 10 with a step of 1. And lastly we will check the splitter also. Splitter have two values in it, best comma random. Now once our parameters are ready, we'll apply grid search once again. And here we will pass DTC parameters and DTC, and we will pass n jobs so that parallel computing can happen. N jobs equal to -1 and verbos is equal to 1. Now we will fit our decision tree, fitting 5 folds for each 6780 candidates. So we will check as there are many parameters in it, so it is taking time for decision tree to get trained over here. Let's just wait for it to get trained. So it got trained. Now we will check the best parameters for it. So it is saying criteria should be entropy, max depth should be 24, minimum leaf sample should be 7. So we will provide all this value and train our decision tree classifier. Once again, decision tree classifier criteria is entropy, max depth is 24, max min sample leaf is equal to 7, min sample split is equal to 4, and splitter equal to random. Splitter is equal to random. Now we will train it. DTC dot fit will pass our X train Y train and will calculate Y pred, that is Y pred is equal to DTC dot predict X test. Now it is trained. We will check the accuracy score and all those things. So it has lesser accuracy than our SVC classifier, that is support vector classifier. It has only 92% accuracy and it has made wrong prediction of 9 data. So finally we will train one last algorithm, that is random forest classifier. So from sklearn.ensemble will import random forest classifier. So rand underscore CLF is equal to random forest classifier, and we will provide the value max depth is equal to 11, and max feature we should give values like auto, and min sample leaves should be 2, and min sample splits should be 3. I can keep it like this. And n estimators, number of loops, and n estimators, and n estimators n job not st, and estimator and estimators is equal to 130. So rand cliff dot fit X train X train Y train So y pred is equal to random forest classifier randcliffe dot predict x test. Now we will check whether it is running or not. And finally we will print all the reports of it. So it is showing the accuracy of 95%. Confusion matrix is also showing that it is not predicting properly 5 values only. So our best model for building is support vector machine, which has got accuracy of 98%. So we will select this and build our finish our model building activity. Thank you guys for this video, and this after this project we will bring another project soon.